Hello. Now we're going to extend the idea of the nature of quadratic roots to situations where we can be asked to find ranges of values for or variables, in this case k, that will give quadratic equations real roots or imaginary or complex roots or repeated roots. So in this situation I have this quadratic here, x squared plus 10x plus 29 plus k. And I'm asked for what values of k will this quadratic have distinct real roots. Well, when I see a phrase like this is a kind of a keyword type thing that we have in this chapter, distinct real roots. If I'm asked about the nature of roots, what am I going to write down? I'm going to write down b squared minus 4ac, my discriminant. And I know that that's what I'm going to need to figure out the nature of roots. But if I'm looking for distinct real roots, I know that I'm going to need b squared minus 4ac to be greater than 0. I need to get a real number underneath the square root sign in my minus b formula in order to get two distinct real roots, the situation we're most familiar with when we're getting the roots of quadratics. So let's put this into practice. What's a going to be for this equation? Well, I have 1x squared, so it's going to be 1. I have 10x, so b is going to be 10. And for c, we have to think a little bit more carefully because all of this, the last two terms here, are constants relative to x. They don't change with x. So that means that my c is actually 29 plus k. Now we're not too familiar with this at the moment, but we will get familiar with this style of thing by the end of our course, that we can have the constants involving a letter. But this is the key thing. All of this is the constant on the end relative to x. It doesn't change with x or y. So now I'm going to sub into my discriminant. So 10 squared minus 4 on 1 on 29 plus k, and I want this to be greater than 0. Well, now I can see I just have an inequality in k, and so I'm just going to solve my inequality. So I end up with 100 minus 116 minus 4k is greater than 0. And if I take that away, I end up with minus 16 minus 4k greater than 0. Now I need to rearrange my inequality. Now I can add 16 to both sides without any difficulty. That won't mess up my inequality. But I do know that there is something I can do that makes my inequalities behave strangely. If I divide or multiply by a negative number, what's going to happen to my symbol in the middle? It's going to flip around. So if I have to divide by minus 4 to get k by itself, I'm going to have to flip around my greater than symbol. So k becomes less than minus 4. So for any value of k that is smaller than minus 4, and we need to be careful with the idea of smaller than numbers, so that would mean minus 5, minus 6, minus 7, minus 8. They're smaller in terms of their meaning, in terms of their value. So for k that is smaller than minus 4, so if k was minus 5 or if k was minus 10, this quadratic would have real roots. It would have distinct real roots. So it would get roots in the way that we're used to equations having roots. Now, I want to show you why that's the case graphically. So what I'm going to do is open up GeoGebra. That's going to change the brightness of the screen a lot. So you have a warning, the brightness of the screen is about to change quite a bit. So this is my quadratic, x squared plus 10x plus 29. And I know that in my algebra that I just did, I had a plus k here. And I know that if k was less than minus 4, I should end up with distinct real roots. So let's look at that. At the moment, what would I get from my b squared minus 4ac, I would get a number that's less than 0 because my quadratic, my orange quadratic here, is way up in the air. It doesn't touch the x-axis at all. But I go into my quadratic here, and I was told if x was less than 4, I would end up with it having distinct real roots. So let's go k is minus 5. What does that do? It means that every y value, so this was my original quadratic, and I've now subtracted 5 from every single y value in that curve. And it's effectively pulled the whole thing down by 5 places in the y direction. And it's pulled it down to the point where it's now below the x-axis. So that means that it's cutting the x-axis now at x is minus 4 and x is minus 6. So it has 2 distinct real roots now, because I've subtracted a number that is less than minus 4 away from my original quadratic. So this is why it's saying that when k is less than minus 4, we're going to end up with 2 distinct real roots. But what would happen, just as an addendum, as a final point, what would happen if we took k being 4, or minus 4, I should say? If k was minus 4, what would happen? I would end up with repeated roots, because now I've brought my quadratic down to where it is just touching the x-axis, where it's a tangent to the x-axis. So I would end up with repeated roots if k was equal to minus 4. But if k is less than minus 4, if I said that it was minus 4.1, I can see that I've now dropped down to the point where I would have 2 distinct real roots. I'd be hitting the x-axis here and here. So I would get 2 distinct real roots. So this is what we're talking about. We're going to go back to a darker screen now. This is why we're saying that when k is less than minus 4, we start to get real roots. This is what the discriminant is doing for us. If we're not able to draw a picture, we can use the discriminant to see what values of k are going to work out. And it doesn't matter whether they give you the variable as the number in front of the x, or the variable in front, or the number in front of the x squared. You're simply going to sub into the b squared minus 4ac formula, and you're going to, if you're looking for distinct real roots, you'll be looking for b squared minus 4ac to be greater than 0. If it asks you for or where it's going to have repeated roots, you're going to be looking for b squared minus 4ac to be equal to 0. And if you're looking for where there are no real roots, or where there are complex roots, you're going to be looking for b squared minus 4ac to be less than 0. So all you're going to be doing is subbing into b squared minus 4ac and looking for the nature of your roots. And that's what we need for the more advanced end of the nature of roots type, or the nature of quadratic roots type questions.